So in this lesson, we're going to look at primarily really how to randomize, whether it's for pulling a random sample or to do a simulation. In class, we're going to compare and contrast the different sampling techniques, and maybe it'll help you understand why we randomize. So in the old days, we basically had these random number tables. So in statistics, random numbers are frequently used to select samples, to simulate outcomes, and assign treatments and experiments. One way to create random numbers is to flip coins. You can also draw cards or roll die. In fact, there were some people who would actually take their die, and they had very well-balanced die, and they would go and they would just generate random numbers, and that was like their job, to create random numbers, and they'd make all these tables so people could have some random numbers to draw from that were like actually random. All right. Now, this is not the easiest way to select random numbers, so that's why they created these tables so people wouldn't have to go around finding a really good die or a coin or whatever they were doing. All right. So a random number table is basically a series of digits from 0 to 9 arranged randomly in rows and columns as demonstrated in the small sample below. So you can see, and you can see it on our screen, you've got row 1 going across the top, column 1. Now, why is there a column on there? It's just for legibility. It's not that, and you'll see a gap, right? So if I were to point this out, let me go ahead and, there we go. So you can see this gap in here. You can pretty much ignore that. Also ignore these numbers at the head. Those are just row numbers. And you can ignore the column numbers as well. The only reason you have this is if I said, okay, guys, we are going to use line 6. So on this random number table for the lesson we're doing today, I'm going to be using these numbers right here, okay? So it usually is organized like this, grouped in 5 digits just for legibility. Now, I will show you some technology because most people nowadays don't use random numbers. However, if I give you a quiz or a test, it's very hard for me to know if you're properly using random numbers unless I give you a fixed set of random numbers already. So you are expected to be able to read a line of random numbers when I give it to you. So let's go ahead and start doing that. So here's a line of random numbers from line 6 at the top here. So first of all, this is usually my job. You're going to select which line to use. And I'm telling you we're going to use line 6. But if you were doing it using tables the old-fashioned way, you would say, oh, let me randomly pick a line so I don't always use the same line all the time, right? Now, steps 2 through 4, you will need to do, all right? You're going to have to determine how many digits you want to use for each outcome, all right? Since we have 100 individuals, so what I'm trying to do is use this table to pick 5 out of 100 individuals for a sample, all right? So you probably are thinking, well, we should use 3 digits. Well, you can actually get away with using 2. In this case, when it's like on the even hundreds or thousands, you can actually use it a digit less when it goes up to 100 or 1,000 or 10,000. Why? Well, I can actually simulate individual 100 by just using the digit 00. So there are a couple different ways. I could say 00 to 99 or individuals 1 to 100, but sometimes it's easier to give that 00 to a special digit because it kind of matches. All right, you also need to determine the range of acceptable outcomes. If we sample the 2 digits, the lowest number we can get is 00 and the highest is 99. Now this is going to match the number of individuals we have, so we won't have any results outside of our range. And I will do some examples where it doesn't match, all right? Now you will frequently want to start at 0 if you're doing 1 digit, 00 if doing 2 digits, or 000 if doing 3 digits. I haven't really seen it used for 4 digits. It could be, but it's not common. But you can probably guess. You do 0000 if it was 4 digits. Then you're going to write down the sets of digits to get the desired sample size. Be sure to ignore repeats and outcomes that are not in your range. So If we had repeats for sampling, we don't normally want to survey or sample the same individual twice. That's why we ignore repeats. And I will show you some examples where we can have individuals or numbers outside of the range for our individuals. So here are the identifiers. First, we're going to highlight 77. That's the first set of 2 digits. Then 92. And then we're going to go 1 to 0. You're probably going, but there's a gap there. Shouldn't I do 0, 6? No, you just keep going in order. Ignore the gap. It's just for legibility. Then do 69 and then 0, 7. So our results are 77, 92, 69, and 0, 7. So if I was trying to pick 5 individuals out of 100, those are the individuals I would pick. All right, so let's go ahead and make it a little more real world. All right, here is a list of movies that have been released so far as of June 2021 that were released widely. So this is the entire list. And you can see that there are 27 movies on this list, right? So how many digits should we use? All right, we're going to, if we're using line 15, remember to ignore the 15 part, how many digits should we use? Well, we're trying to go up to 27 movies, so we're just going to go use 2 digits. 2 digits will definitely give us up to 27. We can go 0, 1 to 27. Now, you're probably going, wait a second, didn't you say start at 0, 0? I could do 0, 0 to 26. It's just a little confusing when the movie's numbered 1 and I use 0, 0 for 1. So you can see, and so the way I can fix that, because I already have a numbered list, is I'll say ignore 0, 0 and anything from 28 to 99. Do we ignore repeats? Yes, we do, because we don't want to sample the same movie twice. So which 5 movies are in our sample? We're going to take these numbers here. We're going to go ahead first and figure out our sets of digits, all right? Now, you'll notice 0, 1 to 27 is not very big. So a lot of our pairs are probably going to be outside. So let's first of all ignore the 15. That was part of the line number, remember? Okay, so we're going to pick 0, 7, then 11, then 99, then 73, then 36. And you probably think, oh, I can probably stop. Yeah, but I see some big numbers in there already. So I'm going to add 5 more. All right, so I'm 5 more pairs just going in order. And let's go ahead and write those down. And let's see which ones are outside of our range, either if they're 0, 0 or higher than 27. So we can see 99 is higher, 73 is higher, 36. 36 feels low, but it's actually higher. 71 is higher, 80 is higher, 81 is higher, and 78. So I didn't get enough digits because I only have 3 identifiers here. So let's go ahead and draw another set of digits. Now we're going to have, let's see, we got 77, 23, 31, 39, and 16. Let's see if that gets us enough. So there they are. And I like to rewrite them. It's just easier to see, right? So 77 is too high, but 23 is fine. 31 is too high, 39 is too high, but 16 is fine. And now I actually had to do 15 pairs of digits in order to just get 5 sets that were from 0, 1 to 27. So this is my sample. I'm going to look at movies 7, 11, 4, 23, and 16. So bringing back up our list, we said there was 7, 11, 4, 23, and 16. So I'm just going to go ahead and go down the list and circle those. 7, 11, 4, 23, and 16. Which movies were those? Well, in the order I sampled them in, they were Mortal Kombat, Spiral, The Conjuring, The Devil Made Me Do It, Voyagers, Peter Rabbit 2, The Runaway. All right, so those are the 5 movies. All right, so how are we going to do this if we're taking a sample? So I could say, what is the average box office revenue? And just do it by taking a sample instead of calculating all 27. We're just going to do 5. Well, I'm going to go ahead and look up the revenues for them. And you can see that's off to the side. So each one of these is kind of like one data entry where it has a different data value categories and things like that. So we're recording a lot of data for each movie, right? So the box office revenue, you can see it's the circled numbers right here. So how do we figure out the average box office revenue? Well, I sampled 5 movies. I'm just going to add them up and divide by 5 and it's 26.18 million. So that's an example of how to take a sample and then record results, whatever they may be, from the sample. There's another way that we like to use let me go over. Now you're probably going, that random number table, we sure had to skip a lot, right? Well, there's also technology, right? And let me go ahead and get rid of my pointer options, laser. Where's that? Screen pointer options. There we go. Automatic. Well, maybe that works. All right. So if you go to this link, you can it's a random number generator, random.org. I use it all the time. And you can say, I want 5 from 1 to 100 and say generate, and boom. In fact, I'll do that one again. Let's do that again. So see how we change. We only need 5 numbers. And we want from 1 to 100. Now, for my movie example, would have been great because I could have said 1 to 27. And that would have been beautiful. And it would have given me 5 numbers from 1 to 27. All right. So there are my numbers, 44, 37. See, I might have to go again to get rid of that 37 because there's a repeat in there. And it doesn't seem, I might be able to say no repeats in advanced mode, but it doesn't seem to be there. So you might even if you're using technology, it is possible for you to get repeats from technology, not just random number tables. All right. So now let's go to the next topic, which is simulation. So you may recall our activity where we explored, can Joy smell Parkinson's? So that was an online applet. How did they simulate guessing 50% right or wrong on the t-shirts? Well, they used random numbers to simulate chance. And they use technology to actually generate those. But we can also do a simulation with a table. And again, if I give you a quiz or a test, ideally I want to know what numbers I'm dealing with. So I'm probably going to, now, I'm not saying you're all going to have the same set of numbers. In fact, I almost guarantee that. But I'll probably give you a row of random numbers. All right, now, if we're doing simulations, we do not ignore repeats, all right? Why is that? Well, you're allowed to have the same thing happen more than once. So there's no problem. It's not like we're using up all the possible outcomes, all right? So we're not sampling where we don't want to have an overlap, where we don't want to like pull the same movie twice. We are doing a simulation where we're trying to simulate guessing, all right? So this is this line of random numbers that I pulled from the table. And when you're doing a simulation, you just want to make sure that the percentage of digits matches the desired outcome. So on this one, if Joy were guessing, what percent of the time should she be correct when guessing which shirt smelled like Parkinson's? Well, she should be right about 50% of the time. And then you can use that percentage to determine which digits reflect each outcome. You will not normally have to ignore outcomes because typically if we're doing a percentage, that does go to 100 or 1,000 if you're doing decimals, or 10,000 or even 10 if you're just doing like 10%, multiples of 10%. So in this scenario, if we were, you could ignore, well, actually your failure is 0 and 7. Sometimes you will not normally have to ignore outcomes, except in very special situations. So this is not the Parkinson's thing. Say you were trying to simulate a 6-sided die. Well, in that case, you only want numbers 1 through 6. So you would ignore anything that was a 0 or a 7 through 9. Or if you wanted to be weird about it and go 0 through 5, and then you say, oh, well, then I'll ignore 6 through 9. You can do that, just depending on how you want to set it up. So the tricky part for us teachers grading this stuff is there's more than one way to do a simulation. And sampling is a little more straightforward, but simulations, there's more than one answer. So sometimes I'll be pulling my hair trying to grade these. So a lot of these work right here. So these are different ways that we could simulate guessing the t-shirts, all right? So we could say, hey, we're just going to use the numbers 0 and 1. If it's 0, we say it's correct. If it's 1, we say it's incorrect. And we ignore 2 through 9 and don't ignore repeats. Well, if you remember from the movie thing, that's only 2 digits that can get me an answer. So A will work, but we'll have to sample a lot of digits. So I don't want to do A, all right? Use the digits 0 through 9, and if it is from 0 to 5, we say the guess is correct. If it is 6 to 9, we say it is incorrect. Don't ignore any digits or repeats. Okay, Well, the problem with this one is 0 to 5 is actually 6 digits. If you count on your fingers, you go 0, 1, 2, 3, 4, 5, and you have a finger up for each one. How many do you have up? You have up 6. 6 out of 10, that's 60% of the outcomes. That does not match the percentage that we were trying to match. We're trying to match 50% for our simulation. Okay, we could use the digits 0 through 9, and if it is 0 to 4, we say the guess is correct. If it is 5 to 9, we say it is incorrect, and don't ignore any digits or repeats. This should work. So 0 to 4 is 5 digits, and it's 5% of the outcomes. I really like this one because it's pretty straightforward, and it doesn't use a lot of digits. I don't have to ignore anything. It's really nice. All right, how about D? Use the digits 0 through 9. If it is even, 0, 2, 4, 6, or 8, we say the guess is correct. If it is odd, 1, 3, 5, 7, or 9, we say it's incorrect, and we don't ignore any digits or repeats. Believe it or not, this one works about as well, all right, because there are 5 evens, and that's 50% of outcomes, and we're trying to match 50% on the probability of guessing it right. How about using the digits? Say you're like, oh, 50%, so a common trick you can do, you say, oh, 50%, so that looks like I need 2 digits there, right? And so I'll use 2 digits, 0, 0 through 99. And then I'll just adjust it slightly. 0, 0 to 49 is correct, and then everything else, 50 to 99, is incorrect. This actually works, okay? It's just a lot of digits. I mean, it's not a huge amount. I'll definitely only need to get 5 pairs, and it'll work fine. It's just, that means I have 10 digits, whereas these other ones, I can do it with just 5 total digits. So I'm going to go ahead and do my 2 favorite methods, which are C and D. All right, so using C, we say, if it is from 0 to 4, we say the guess is correct, and we're only doing 1 digit at a time, all right? And so my first outcome is a 1, and then a 0, then a 3, then a 6, and then a 5. So if the ones that are from 0 to 4 are correct. So those will have C's, and I can see the only ones, the first 3 are from 0 to 4, and the second 2 are from 5 to 9. So those 2 are incorrect. So I have correct, 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 incorrect, incorrect. So on this simulation, we got 3 out of 5 correct, or 60%. So now let's look at method D, so where we're using the even and odds, all right? We're still dealing with the same 5 digits, 1, 0, 3, 6, and 5. But now since we say evens are correct, we can see that 0 and 6 are even, but 1, 3, and 5 are odd. So we have incorrect, correct, incorrect, correct, incorrect. All right, so that means that we get 2 out of 5 are correct, and that's basically 40%. So 2 different methods are giving us 2 different results on the outcomes, or 2 different, it's the same simulation or same set of random numbers, but because the simulation is set up differently, we get a different result, which is why grading these can be so much fun. All right, so let's say we are trying to simulate a baseball player who bats .278, or basically 27.8%. Now, a lot of you, I would not expect you to know what to do with .278 unless you're a baseball fan. When someone bats a .278, that means they get on average, they get 278 hits out of 1,000. Well, if I change that to percent, it's 27.8%. Well, how many digits do we have in there? Well, you can see there are 3 digits, either way you look at it. So I'm going to use 3 digits in my random number table. Which outcomes would I use to simulate a hit? Well, I need 278 digits. So there are 2 ways to do that. I can just go 0, 0, 0. Remember, I'm starting with 3 digits, so I'm probably starting with 3 zeros, to 277 is a hit. Now, you may say, oh, I feel a lot better with the 278. So you're going to start at 0, 0, 1 to 278. So those are 2 different plans I could grade. In fact, technically, you could pick any set of 278 digits. If you wanted to list them individually, you could, but I wouldn't do it. So try and keep them all together so it's easy to do and you don't have to look it up. So which ones would we ignore? I'll show you both ones that we would ignore. So if you're picking that first set there, 0, 0, 0 to 277, then that means you want to ignore the balance, 278 to 999. Now, if you pick the second method, then you're going 001 to 278 because it better matches kind of what you're working with, which is fine. Just make sure that you also ignore that 000 and the 279 to 999. So that kind of gives you a rough idea how to set up a simulation. So what were the big ideas in this lesson? Well, we can use random numbers to sample data and to run simulations. When sampling, it is important to ignore repeats since we don't want to sample the same individual twice. And when using a random number table to sample, we have to decide on how many digits to use and which to ignore. So decide whether you're going to start at 0 or ignore 0. So you saw I gave two outcomes, one where it started at 000 and the other one where it started at 001. It's up to you which one you want to use. Just make sure it all matches and you have the right number of outcomes to match your percentages. If there are 100 individuals or less, we can use 2 digits. If there are 101 to 1,000 individuals, we can use 3 digits. Although I'll tell you, if it's like 101 individuals, that'd probably be a mess. I'd probably use technology instead because I'd have to ignore pretty much 102 to 999 and 000. So that would be a pain. All right. So there are certain times, but if you're doing a random number table, that's actually what you would have to do. All right. When using a random number table to perform a simulation, or even random numbers in general, honestly, whether it's technology or whatever, we should use the modeled percentage or probability to determine which digits reflect which outcome. So for percentages to the nearest percent, we can just use 2 digits. You saw in that last example it was to the nearest 1/10 of a percent, and in that case, we wanted 3 digits.